Okay. There we go. Okay, so we're finishing off the examples in lesson 2.2. All right, so first of all, it says sketch the graph in the following function. So, okay, now, I'm sketching this the new way, right? Not the old way. I'm not sketching the square root of x as a parent function and then stretching it by a factor of 2. I am going to graph the line y equals 2x. So what do I know about the line y equals 2x? Well, the line y equals 2x goes through 0, 0. It has a slope of 2, so I go up 2 and over 1, which means I could go down 2 and left 1. And then that's the original line. I'm going to make this. This isn't the one I want to graph. So I always make the thing I'm kind of basing my graph on a dotted line. So this is my parent function now. What's happening to my parent function? Well, it's first of all being square rooted. What does that mean? It means that 0, 0, and I guess this is 1, whatever that, or 1 for the y value, whatever the x value is. I guess it's probably a half. Yeah, it has to be. It's a half. Those have to be invariant points. And then, you know, I could figure out another point by going, okay, I know that 2 becomes like, when you square root 2, you get about 1.4. So I don't know, maybe about there. And when you square root 3, y is 3, you get, I don't know, about 1.7. So here we go. Now, if you're, and don't forget there's a little bit of a bulge here. And if you're wondering, how come he didn't change colors? And how come he's still drawing a dotted line? How come? Because I'm actually not done yet. This isn't my final graph. I still got one more thing I got to do to it. Yeah, I got to do the negative. So now all I have to do is take my dotted line and now make a solid line that reflects that. So that point stays the same. This point moves down to here. This point moves down to, so that's 1 and a bit. I don't know, 1 and a bit, good enough. And this is, looks like it's about halfway there. So about halfway, maybe about there, something like that. So good enough. Okay. So there we go. That's how I would do that one. Okay, so, okay, come on, erase, erase, erase. There we go. Okay, next, square root of x plus 3. So again, I'll start with a parent function. So my parent function is basically just y equals x. The easiest line to graph, just go through corners. And there we go, y equals x. But it is being square rooted, which means 0, 0, and 1, 1. And, you know, again, it's doing that. Now it's being shifted 3 up. So my final answer will be take that second dotted line I make and shift it up to 3. So it's starting up there. And then 1, 2, 3, and then curved up that way. There we go. Sorry, that one's a little off the screen. Okay, moving up. They don't trust you anymore on C. They factored it for you because they just knew you were going to forget. They're insulting your intelligence on this one. Okay, so for this one, interestingly enough, I actually don't really need it factored to graph it this way because if I was graphing it the 2.1 way, then yeah, I kind of need to think about, I need to think about it that way. But in the 2.2 method, this is my parent function. Sorry, come on, highlight, thank you. This is my parent function. So it's easier to graph a line like this than it is like that. So I'm actually kind of going to ignore that and just graph it. How do you graph 2x minus 4? It has a y-intercept of negative 4, and it has a slope of up 2 over 1, up 2 over 1, up 2 over 1. Dotted line. Okay, now let's make our graph. We're square rooting that. So 0, 0, or sorry, 2, 0 is an invariant point. And 1, looks like that's 1, 2.5 is an invariant point. When y is 4, it would square root down to 2. So there we go. That's 3 points. That's enough. And I do remember that there is a bit of a bulge there. I should see a little bit of gap between the dotted line and the curve. And I think I did warn you the other day, don't exaggerate it. Yes, we are looking to see that you know there's a gap there when you draw these, but we are forced to take off a mark if your diagram suddenly goes, wow, like that. Too much. It won't cross backwards over the x's 2 mark. Okay, so make sure you understand that. Now we finally hit one where I don't think I would have even tried to do this one by the chapter 2.1 method. Okay, because there's no real parent function to be had by knowing the square root of x squared. I mean, the square root of x squared is just linear. Is this thing going to end up looking linear? No. So what I'm going to do with this one is draw the parabola y equals x squared minus 3, which goes through here. It has x-intercepts at, well, let's see, when that is equal to that, I'm going to get x squared is equal to 3, so x is equal to plus or minus the root of 3. Okay, this is where I'm using my estimation skills. I know the square root of 3 is about 1.7, right, roughly? So about there and about there. I'm supposed to be doing this in blue. This is my parent function, there, there, and there. So here's my parent function, Okay, and I think, you know what, I think I curved this too much. I'm going to go back. I'm going to try to make my eraser work. There we go. I think that's probably right. No, now it looks stupid. Oh well, it'll. Okay, what do I know? I know that the zeros are invariant points. I know that when y is 1, I get an invariant point. I'm pretty sure that happens before I get to an x value of 2. I could check that. It's really easy to find those invariant points. You just literally set y to 1 and you solve. And, oh, you know what? It actually does. I'm redrawing this. This actually does go through the points. Let me go back to the blue. It actually goes through 2. So that should be an exact, easy to find invariant point. There we go. So now my invariant point is actually right here when x is plus or minus 2. So there it is, plus 2 and minus 2. Then I know that I make a little bit of a bulge that way. And again, I've probably exaggerated that a bit, but you get the idea. Something like that. Good enough. Okay, any questions on how I did that one? Okay, I've been kind of ignoring part of the questions here. Domain and range. Let's get back to that. This domain is x is greater than or equal to 0. This range is y is less than or equal to 0. This domain, let's see, where are you? Where are you, graph? Oh yeah, you're way up there. So your domain is x is greater than or equal to 0, but my range is y is greater than or equal to 3. What about these two? Well, my domain is x is greater than or equal to 2, and my range is y is greater than or equal to 0. This one's where it gets a little harder. I have to write this in 2 parts. X is greater than or equal to negative 3. Sorry, I meant to say less than. I wrote it right. Less than or equal to negative root 3. And x is greater than or equal to positive root 3. Now, don't do this. I will get students who, because they have a little bit of knowledge, they're fairly good at understanding how you write down set notation. They'll just do this. They'll say, oh, I can write that in one statement. And And I have to mark that wrong. You're only allowed to make it one statement like this if these two symbols have the same direction. And what that actually means is that the graph is continuous. It doesn't have a gap in space between where the domain exists. You're not allowed to write it this way, so please don't. If this was a provincial exam year, this is one of the things they always tell those of us marking it to look for and take off a half mark for. It's a communication error. You are not allowed to use set notation to express the domain of a non-continuous function in one statement. You have to do it in two statements. If you decide you'd rather do it in, interval notation, you can use an and, but you still need two statements. You'd have to say, I start from negative infinity and go up to the square root of 3 negative, and I start at the square root of 3 positive, and I go to positive infinity, and here's the symbol for and, if you want to use set notation. It's called the union symbol. It basically means and. But notice I can't make that one statement either. Right? If I said, it's like, well, why can't you just say from negative infinity to infinity? Well, then how do you account for the fact that there's a hole in there? Okay, so it can't look like that. See the problem? Set notation has the same problem. What do you put between these two things, somebody's asking? A curve, or a comma. You just put a comma, that's fine. Okay? So any question about that one? Range, on the other hand, you can say in one statement. Range, you can just say, oh, yeah, it starts at 0 and goes up forever. Okay, so now this one here, it says using another method. So in other words, they want you to go back to the 2.1 method. So this is the 2.1 way of doing it. So how do we do this one the 2.1 way? Well, if we do it the 2.1 way, maybe we should have done that first because that was where it was already factored for me. So I have to start with my parent function of the square root of x. So this is back to 2.1 for 2, right? Badoo, 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 badoo. And then I go, okay, I times y values by 2. That doesn't change 0, 0. And then I move it 2 to the right. So there's the new vertex. The 0.11, the x value gets, oh sorry, the x value doesn't get times by 2, it gets times by a half. I meant to say times by a half. So this value gets times by a half, which just puts it there, and then moves 2 to the right. So 1, 2, so now it's here. So this point here gets the y value, the x value gets cut in half, so now it's at 2, and then it moves 2 to the right, 1, 2, so it's actually there. So there it is. And I should look, is that the same graph I had above? Yep, there it is, and there it is. Okay, and now F, dealer's choice. What would you like to do? Do you want to use the first method or the second method? Your call. I kind of like the first method better when it's a nice, easy, linear one, right? I've done these so many times, I don't know if I even need the parent function anymore. I know that I start at 0, 0, but now I start 1 to the left, right? And then I know I go to the 0.11, but now I go 1 to the left. I know I go to the 0.42, but now I go 1 to the left. When they're easy like that, I think method from 2.1 is the easier method. I didn't have to bother graphing a linear line through x plus 1. Agreed? You can disagree if you like. If you like, no, it's like, no, 2.2 makes way more sense to me. Then by all means use 2.2. But certainly, there is no 2.1 way to do question D. You kind of have to do it the 2.2 way. Okay? All right, G. We're down to about 10 minutes. I thought we could finish this. All right, what's this one going to look like? Well, first of all, we are going to maybe have to do a little bit of algebra to find our parent function, because our parent function is a parabola that has a y-intercept at 4. Very nice of them to give me a grid that doesn't go that high, but okay. And it's got a negative in front of its x squared, which means it goes down. Thank goodness, or else we wouldn't see any of it on this grid. So it goes down. You might want to do something like look at the parent function and figure out its x-intercepts so that you have something to graph with. So x-intercepts happen when y is 0, right? So move the 4 to the other side, and it's negative 4. Divide both sides by a negative, and you get 4. Square root both sides, you get plus or minus 2. At this point, you should all be having grade 11 quadratic flashbacks. And then minus 1 from both sides. So, whoops, come on, pen. There we go. X would then equal negative 1 minus 2, which is negative 3, or negative 1 plus 2, which is 1. So there we go. I have x-intercepts at -3 and 1, and I have a vertex. Oh, wait a minute. This is actually not the right y-intercept. I just realized something. That's not the right point. I have a vertex. Let me write that down. My vertex is, what is it again? It's -1, 4. So -1, 4. That's the point I wanted. The x-intercept, what would the the y-intercept, what would the y-intercept be? The y-intercept happens when x is 0. So when x is 0, let's just think about it in this function. When x is 0, I'd get -1 plus 4. Oh, I'd get 3. That's the right answer right there. There we go. Okay, I'm ready to graph this now. I can use symmetry. I'd know that'd be a point too. And if there's people who are going, wait a minute, I don't remember how to do the things you're doing. Well, I wish we could spend a week doing grade 11 review, but we cannot. That is the deal with this pre-cal stuff. It really does demand that you remember your grade 9, 10, and 11 skills. And we just kind of put them to use learning new things. And if you think it's bad here, wait till you see what they're like in first year calculus or first year linear algebra. There is just no time to review stuff. It is completely on you to have mastered high school math. They're quite brutal in that sense. Okay, what do I do with this thing? Well, I know that I have my invariant points here. Come on, pen. Here, 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 and here. Okay? This is a value of y is 4 up there, so the square root of that's going to be 2. The x values don't change. So this is the one I called the mushroom. Again, it does bulge a bit, which is hard to kind of see here. And then it goes, it's a nice curve, and then it goes through that point. Again, it bulges a little bit past it, and there we go. Something like that. And once again, they want domain and range. This time, I can use one statement. X is greater than or equal to -3, but it's less than or equal to 1. Because it's a continuous line. Range, I can do the same thing for range. I can make a continuous statement. Y is greater than or equal to 0, but it's less than or equal to 4. No, sorry, not 4. 2. Sorry, I was looking at the blue line for a second. And then there is one more type. And here it is. What does the parent function of this guy do? Well, the parent function here is y equals x squared plus 2. So that is just a parabola that's been shifted up 2. And then it would go up 1 over 1. And that's all I'm going to have room for on this grid. So I might as well just, whoops, I meant to write that dotted. So I might as well just draw what I've got here. There we go. What does the square root of this thing look like? Well, the square root of this thing is, the square root of 2 is about, I don't know, 1.4, roughly here. 1.4, come on, pen. 1.4. There. The square root of 3 is about 1.7. Square root of 3 is about 1.7. This looks like it's about where 4 is. That would jump down to where 2 is. So I don't know, maybe about there. Maybe about there. I'm estimating at this point, but you get the idea. Smile. I think I've maybe curved that more than I should have. Yeah, this side's too curvy. Let's make it a little flatter. There. What's my domain for this guy? Easiest half mark you're ever going to get. What's the range? Well, I like exact answers. So I'm going to say that the range is y is greater than or equal to, what is that? The square root of 2? There we go. You could write 1.4, I guess, if you wanted to. And that's it. That's the examples we didn't get to yesterday. There's still 2 on the page that say extra practice, so I'll let you try those, and we can go over those next class. And then, of course, it's the 2.2 homework page, which comes up after that. So that's the homework for the weekend. Some of you probably started it already. And if you actually managed to finish it already, look at that. You're homework free. Isn't that nice? We do 2.3 Monday, and then we start Chapter 3 on Tuesday. And Chapter 2 and 3 are going to roll together to make your next test. right? Neither of those units is big enough for its own test, basically. So there we go. Let me stop my video. Come on.